Introduction to Risk-Based Inspection, RBI, per API 580 Recommended Practice, Enhancing Inspection Efficiency Through Risk Assessment Methods. Introduction to Risk-Based Inspection, RBI, Definition and Purpose of RBI. Risk-Based Inspection, RBI, is a structured and systematic methodology used in the process industries to develop inspection plans that are focused on risk rather than fixed time intervals. As defined in API Recommended Practice, RP 580 and 581, RBI integrates engineering knowledge, operational experience, and inspection data to evaluate the likelihood and consequences of equipment failure. The fundamental objective of RBI is to ensure mechanical integrity while optimizing inspection resources, minimizing unnecessary inspections, and focusing attention on high-risk equipment. RBI primarily addresses the risk of loss of containment from pressure-containing equipment such as pressure vessels, piping, tanks, and associated components. In the RBI framework, risk is defined as the combination of probability of failure, POF, and consequence of failure, COF. This approach represents a significant evolution from traditional inspection philosophies that relied heavily on prescriptive codes and fixed inspection intervals. RBI allows organizations to make informed, defensible decisions that align inspection activities with actual risk levels, improving safety, environmental protection, and economic performance. The API 580 update further emphasizes alignment with asset integrity management systems, lifecycle thinking, and continuous improvement through reassessment as operating conditions, degradation mechanisms, and inspection results change over time. The primary purpose of risk-based inspection is to provide a rational basis for determining what equipment to inspect, how to inspect it, and when inspections should be performed. RBI shifts the inspection philosophy from a compliance-driven activity to a risk-informed decision-making process. According to API RP 580, RBI aims to reduce the risk of failure to a level that is as low as reasonably practicable, LARP, while ensuring compliance with regulatory and corporate requirements. The methodology supports prioritization of inspection resources by identifying equipment with higher risk profiles, thereby improving overall plant safety and reliability. RBI also helps extend inspection intervals for low-risk equipment, reducing inspection costs and operational disruptions. Another key purpose of RBI is to provide transparency and traceability in inspection planning decisions, which is particularly important for audits, regulatory reviews, and management approvals. By combining quantitative or qualitative assessments of degradation mechanisms, inspection effectiveness, and consequence modeling, RBI ensures that inspection strategies are technically justified and aligned with actual operational risks. Traditional time-based inspection approaches, risk-based evolution of inspection intervals. Traditional inspection practices in the process industry have historically relied on time-based or calendar-driven inspection intervals. These approaches are typically dictated by codes, standards, or regulatory requirements that prescribe fixed inspection frequencies regardless of actual equipment condition or service severity. While time-based inspections provide simplicity and regulatory clarity, they often fail to account for variations in operating conditions, material degradation rates, and inspection history. As a result, equipment with low degradation rates may be over-inspected, leading to unnecessary costs and operational downtime, while high-risk equipment may not receive adequate attention. Time-based inspection also tends to be reactive, identifying issues only after degradation has progressed significantly. API RP 580 recognizes these limitations and positions traditional inspection as a baseline that can be enhanced through RBI methodologies. The evolution away from purely time-based inspection reflects the industry's growing emphasis on reliability, safety performance, and risk management. Under the risk-based inspection framework, inspection intervals and due dates are determined by evaluating both the probability and consequences of failure rather than relying solely on elapsed time. API RP 580 emphasizes condition-based and risk-informed intervals, where inspection timing is linked to degradation rates, remaining life calculations, and risk acceptance criteria. Equipment with low POF and low COF may qualify for extended inspection intervals, while high-risk equipment is inspected more frequently or subjected to enhanced inspection techniques. This evolution enables more proactive management of equipment integrity by anticipating potential failures before they occur. RBI also supports dynamic reassessment, meaning inspection intervals can be adjusted when new data becomes available, such as updated corrosion rates, changes in operating conditions, or results from advanced inspection methods. This flexible and adaptive approach improves safety margins while optimizing inspection planning and maintenance resources. Understanding consequence of failure, COF categories and examples. Consequence of failure, COF, represents the potential impact that could occur if a piece of equipment were to fail and result in a loss of containment. In API RP 580, COF is evaluated across multiple dimensions, including safety and health impacts, environmental damage, economic loss, and business interruption. Safety consequences may involve injury or fatality to personnel due to fire, explosion, or toxic release. Environmental consequences consider the extent of pollution, contamination, and regulatory penalties. Economic consequences include repair costs, production losses, and reputational damage. COF can be assessed qualitatively using consequence categories or quantitatively through consequence modeling that estimates affected areas. Release rates and escalation scenarios. Understanding COF is critical because it ensures that equipment with potentially severe impacts receives appropriate inspection and risk mitigation, even if the likelihood of failure is relatively low. API RP 580 categorizes COF into defined consequence levels ranging from low to high, allowing consistent comparison across equipment items. Low COF typically involves minor leaks with negligible safety or environmental impact, while high COF may involve large releases of flammable or toxic materials leading to fire, explosion, or widespread environmental damage. Examples of high COF scenarios include rupture of high-pressure hydrocarbon piping, failure of vessels containing toxic substances, or catastrophic tank failures. Medium COF scenarios may involve localized leaks that require repair but do not escalate into major incidents. By clearly defining and categorizing COF, RBI practitioners can objectively assess potential impacts and integrate them into risk calculations, ensuring inspection planning reflects not just how likely a failure is, but how severe its consequences could be. Definition and concept of probability of failure, key factors influencing POF. API RP 580 categorizes COF into defined consequence levels ranging from low to high, allowing consistent comparison across equipment items. Low COF typically involves minor leaks with negligible safety or environmental impact, while high COF may involve large releases of flammable or toxic materials leading to fire, explosion, or widespread environmental damage. Examples of high COF scenarios include rupture of high-pressure hydrocarbon piping, failure of vessels containing toxic substances, or catastrophic tank failures. Medium COF scenarios may involve localized leaks that require repair but do not escalate into major incidents. By clearly defining and categorizing COF, RBI practitioners can objectively assess potential impacts and integrate them into risk calculations, ensuring inspection planning reflects not just how likely a failure is, but how severe its consequences could be. Several key factors influence the probability of failure in an RBI assessment. These include the active damage mechanisms such as corrosion, erosion, fatigue, or cracking, the rate at which these mechanisms progress, and the effectiveness of past inspections in detecting degradation. Operating conditions such as temperature, pressure, fluid composition, and process variability also significantly affect POF. Equipment design, material selection, and fabrication quality further contribute to inherent reliability. API RP 580 emphasizes the importance of inspection effectiveness, recognizing that high-quality inspection methods can significantly reduce uncertainty and lower calculated POF. By systematically evaluating these factors, RBI provides a realistic and defensible estimation of failure likelihood. Risk calculation and risk matrix, benefits and conclusion of RBI implementation. In risk-based inspection, overall risk is calculated by combining probability of failure and consequence of failure, commonly expressed as risk equals POF times COF. API RP 580 uses risk matrices and ISO risk concepts to visually represent and rank equipment risk levels. These tools allow practitioners to quickly identify high-risk equipment and prioritize inspection and mitigation activities accordingly. ISO risk lines represent combinations of POF and COF that result in equal risk, helping define acceptable and unacceptable risk regions. This structured risk visualization supports consistent decision-making, aligns with corporate risk tolerance criteria, and facilitates communication between engineering, operations, and management. The implementation of risk-based inspection in accordance with API RP 580 provides significant benefits to asset owners and operators. RBI improves safety by focusing attention on equipment with the highest risk of failure and most severe consequences. It enhances inspection efficiency by allocating resources where they provide the greatest risk reduction. RBI also supports cost optimization by extending inspection intervals for low-risk equipment without compromising integrity. Furthermore, RBI promotes continuous improvement through periodic reassessment as new data becomes available. In conclusion, RBI represents a mature, engineering-based approach to inspection planning that integrates POF and COF to support informed, defensible, and effective asset integrity management decisions.